Welcome everybody to Weekly Quantum World Detangled, Season 3, Episode 3. I am joined by my friends Denise Ruffner and our sponsor IonQ.
Hi everyone, Denise Ruffner from IonQ. I put a sticker on my shirt because Tommaso and our guests are all wearing logo clothing and I felt left out. I'm coming to you from Southern California. Yeah, everybody's showing their logos. Tommaso, come on, let's see your logo.
Sure.
There it is. Okay, so welcome everyone, and let me hand it over to Tommaso.
Sure. Hi, everyone. Tommaso from Entropical Labs, calling you as usual from Singapore. And just to say, so I have only one of these beautiful t-shirts left because I've given all the others away. So every time we record, I have to make sure that it's nice and clean and ready for that. Pleasure to be here again.
And we are joined by not one, but two special guests calling in from Poland. Please introduce yourself.
Hi, hello. It's very nice to be here. Thank you for the invitation. My name is Paulina Mazurek, and here is Wojtek Burkot with me. We are the founders of Beit.
And maybe we can start with that story. How did the two of you meet, and how did the two of you decide to work together and start a company in crazy, spooky quantum technologies?
Yeah, happy to. So we've been working together for the past 20 years or so. We first met at Motorola and then moved to set up Google engineering office in Poland, where I moved to a little bit different role in terms of supporting startups and building the startup ecosystem in Poland. And then Wojtek shared with me his idea about quantum physics he had in mind since his teens years, and then we've decided that once we think this is the best time for a quantum company to start, we'll do it. In the meantime, we moved to support Allegro. Wojtek used to be CTO for Allegro, and I was responsible for building tech brand for them. And it was a pretty nice project. But after 2 years, we were like, okay, first quantum computers are really small, and you all know how it works, but are there, and we can start doing something on this equipment and preparing for the bigger machines. So let's do it. And we've invited the friend of ours, one of the best mathematicians in Poland, Witek Jarnicki, who joined us, and this is how it happened 3 years back.
And Paulina, I think you started your career as an admin, an assistant, and now you're the CEO of a successful quantum company. That's a pretty crazy, impressive ride.
Thank you. But you know, this is why I need to bring Wojtek together with me if anyone wants to ask difficult technical questions.
All right, so let me butt in here and say something, how it really started. So I was hired to start and run Google engineering office. And Google decided, rightfully, that I need the admin help. If you like Pratchett, for example, there's ladies who organize and meticulously maintain relations over Form 3B, or essentially somebody who know how to deal with all this. And that's why we posted an ad for the admin assistant. And Paulina, whom I knew from Motorola as an admin, applied. And guess what? In the initial interview, she said that she's not so much interested in an admin role. So I hired her.
And Wojtek, you and I once had a conversation about hindsight. I don't know if you remember that. I don't have a question for you, but I just want to read something to you. And maybe you'll have a response about something personal, a book that I know you're familiar with, The Art of War. And Jun Chu said, "Doth what enables the wise sovereign and the good general to strike and conquer and achieve things beyond the reach of ordinary men is foreknowledge."
Well, what can I say? The master had spoken, right? And that's I am and André knows this. I'm the martial artist. I'm practicing Koryu Jiu-Jitsu for the last 25, 30 years. And this is it, right? You need to be prepared for the opportunity. And once it shows up on your doorstep, you have to grab it. And there's nothing more in this. And we try to use those principles in Beit fights.
And Beit.Tech and I decided to put a quantum fight club together. So Christopher, expect a phone call from us very soon.
Very many jokes about how it would go. Yes, I'm still in.
I wasn't joking, but let's table that conversation and learn more about your company, Denise.
So it's always a pleasure to see you both. Thank you for joining us. Wanted to start off with a really stupid question. How do you pronounce your company name?
This is not a stupid question at all. And, you name it as you want it and you pronounce it as you prefer, because this is quantum name. So if you tell Beit, that's fine. If you tell Beit, that's fine. We usually call it Beit, and this comes from Jewish, meaning home. But if you use the capital letters to write it, then it's belt, and it's like, trying to do something and getting on the speed in order to achieve your goal.
And I call it bite, so I'm completely wrong.
Oh, definitely. It's like bite. No.
But it works too.
Completely wrong. Okay, once again, that's okay. Wanted to talk to you both. I've heard that you've gotten some new funding from the European Union and the Atomic Angel program. So maybe you could tell us about that a little bit? No? Am I wrong again?
Uses this money to support Beit.
Of course.
Arm's length.
I cannot do it. And I was invited to the Atomic Angel program as the angel to invest the money in one to several companies, preferably from the EU, which are very early stage. And actually, there are no strict rules about what these companies should do, which areas, etc. I'm very, very interested in deep tech companies. So it may be whatever, but deep tech that really makes sense, makes the difference. And this is also what we are searching for our companies from Bitspiration Booster. So this is the logo for VC. We ran very, very small Polish VC, just trying to make the difference on the VC stage in here. And as for Beit, we've applied for another EU grant, and we have another panel with specialists in 2 days. So we are working on the financing stuff all time.
Well, good. I wish you well. I know those are a little stressful sometimes. Good luck with that.
Thank you.
And I know I'm skipping around, but one of the things in past conversations we've talked about is that you have a very successful program in hiring undergraduate researchers and training them. And that's very different from many of the other startups who are very focused on hiring PhDs. And so I was wondering if you would talk a little bit about your program with undergraduates and maybe why and how you select and give some context out there.
Of course. So, we're based in Poland, Krakow. You have several technical universities here using the old school of math and hard sciences. So there are very bright minds in here in the region, but there are no quantum companies. We're one of the two that were actually started in Poland, and right now we are the only one. Exactly. So this is pretty hard to find specialists willing to work with us in Poland and on such a difficult stuff, difficult to understand even for people who are deep in tech but not deep in quantum. So we decided that since Beit.Tech used to work on this quantum physics for the past 30 years, even if not for business purposes, then at least in his head, he's the best trainer for the newcomers. So it's easier for us to get like really smart brains on board in here and have them learn from Beit.Tech by working directly with him. And it pays off. So it took them something about half a year to really get on and being able to shoot their own ideas and to match facts and to bring new ideas and work on new projects and give us the new perspective on some areas. So this works that way.
I profoundly disagree. So it's not my experience being transferred to those youngsters. It's the old Google principle of hiring people better than we are. And for the mathematician, the language of the quantum computing is very, very simple. You are doing linear transformations over the complex numbers, full stop. It is simple for people with the right education. However, intuition about the consequences, what's computable, what's not, takes a special approach. And I'm seeing my role just as an inspiration. So original idea as a physicist, right? So vague and hand waving, and then get mathematicians to work on that in detail, challenge me, make it more refined. I can use one of our publications as an example. The original idea of using small diffusion operators was mine, and I've seen how they could work. So was the mid-circuit measurement. But it took them to be actually able to prove the scaling. The advantages we shown on the existing hardware in real life are scalable. And that part, because there is no hardware yet to prove it in practice, was proven formally by just pure mathematics. And that's how we work together and how the description of the idea, if it cannot be shut down by the more rigorous thinking of mathematicians, can be expanded into something of value, like the word best results in the unstructured search, because of the unique techniques which we used.
So are you looking at mathematics undergraduates or computer science? Do you have a...
Whoever can pass our intro exams, right? And this is tough. It's not tough because of me. It's tough because of guys who, for example, in the IBM quantum challenges, usually place in the top. That's the skill. You need too much because we want somebody better than us, right? So that's, and we do talk with people at that level, right? So frankly, we don't care about the formal education and what that was. We do care about really showing that the candidates are, at least in some respects, adding value to the company, meaning being better than us in some of the areas of interest. And we are really serious about that part.
What we do, we actually check how they think, their combinatorial skills, problem-solving skills, etc. So more globally, we don't care if that person has strict knowledge, but how fast she or he can just learn this stuff.
So typical sequence in our interviews is, do you know about this problem? And here there is a branch. If the person says yes, then we move to something else, because I don't want to learn the textbook description of the solution for the problem, right? We tend to explore we are working at the frontier of science, right? So textbook is of limited use. The ability to work in the faced by the unknown is something much more important, and we search for that actively. And the other branch obviously goes like, well, I never heard about this. Fantastic, let's talk about that. How would you solve this?
Okay. And I wanted to ask, are you guys in your office, or what's it like with COVID in Poland?
Okay, so
As everywhere else.
As
almost.
everywhere else?
I will not criticize our government and their decisions, at least not here, but we are allowed to come to the office under some restrictions, so we try to do so. As the youngsters are actually, so they are really willing to work together from the office at the whiteboard, and it really helps them. So we try to be here for them.
Okay. That's great. That's great. As you can see, I'm at home. Tommaso is in Greece. So I'll hand over to Tommaso and he can tell us about his vacation in Greece through Singapore.
It's beautiful here today in Crete.
Sunshine.
Right. Hey guys, nice to see you again. So a bit of background. We actually went through, so we meaning Entropica and Beit went through the Creative Destruction Lab at the same time, a couple of years ago. So thanks for joining us. And I'll try to dig a little bit more into the technology. And something that I've noticed by checking the papers or the publications we've been sharing in the last few months is that as a company, you seem to be quite focused on this idea of quantum search, at least using quantum algorithms. Let me just say for search, and I will let you in a second explain what you mean by that. Then, you know, working in a startup, I know how important it is to focus on resources. And every time you pick a problem, it means you're not picking another problem to look at. Then the question for you is, why the focus on quantum search algorithms? And what is your hope, or doesn't have to be a hope, what is your goal with that?
All right, I can take this one. And the answer is really simple. It's just PR, right? The PR done our way, in a sense that we demonstrated capabilities beyond the state of the art. And you know as well as I do, the work of Google trying to predict the scaling behavior of various quantum algorithms, and establishing that the quadratic speed up, which is something which you cannot do better in the unstructured search, where there is no structure to the underlying data, you cannot do any better, and it might not be enough, because the break-even point against the classical computation is in their opinion, at the point where the classical computation takes hundreds of years, right? So we did two things. First, we attacked constants which were leading to that number, and we were able to reduce them by a factor of 10. Meaning not now it's not 300 years, it's just 30 years of the classical computation which we are trying too much. There are other startups in the areas close to ours, but slightly different positions in the software stack for the quantum computers, attacking the same constants from the other angle. So you can assume that eventually together we'll be able to make that break-even point to something which classically takes several years, a couple of years, right? It's not enough. It's not a good justification for usage of quantum computers, but in order to establish us, coming from Krakow, right? We are incorporated in Delaware. We are a global company. We are hiring for Toronto office. Nevertheless, we are considered to be a Polish startup. In order to be recognized among the much stronger players, you had to do something which was hard for them. And that's how we, having the original idea, which I had like 20, I'm old, right? So it was really long time ago, very early before the startups appeared in that space. We built on that. And the result, we patented 9 different technologies based on just what we did. Maybe the unstructured search is not important in itself, but as a subroutine, if you are placed in the right level of the software stack, we can speed up any computation at the higher level, the most relevant ones, by a factor of 10. Is it worth something? It's worth 3 years of the time advantage in the competitive market. if you use our technology for anything. It's not just search, right? We have proven that with search, but we can use the same techniques to translating higher level quantum computing software constructs into the elementary gates. And we are saving anybody in that market 2 to 3 years, depending how you count. And we can actually substantiate that claim because that's how the growth of the quantum computers happens in time. So that's one thing. And the other thing is that we are now turn our focus into getting super polynomial speedups, and again, working at the pretty basic level of common part of all the quantum computing algorithms. We early on discarded some direction and some ideas, and we still maintain that working on the high-level SDKs and the development environment is premature once you haven't established those basic layers of both the hardware and low-level software. I might be wrong in assuming that the growth and development of quantum computers will follow the path of the development of the classical ones, but I'm old enough to remember programming in assembler language to squeeze every bit of performance from the computer when I needed that, as the physicist early on working on huge, complex physical stuff. So that's the reasoning, and by no means we think that the search is the end of it. It's just showing the capabilities of the team and working on the IP in the crucial layer for any quantum computer and any application.
All right. So I'm not really familiar with the details, but of specifically of the result that you just mentioned. Is this something that, and I guess is also interesting for the people listening to know a little bit more about that. Is the result that you just mentioned a mathematical result, or I guess have you tried any smaller instance on existing quantum computers? Which actually takes me to another question. How do you work with the existing quantum processors out there? Do you have any favorite platform? Do you have a strategy in that sense?
Well, again, selling the company secrets, right? We try to keep equal distance from the huge players in that market for the reason, right? Our product is an IP. And I've been at the Google during its battle in patent war against Apple and against Oracle following Sun, after Sun acquisition, to know how it plays between the big guys, right? We stand absolutely no chance of enforcing our IP on our own. There is no way you can do that against large corporation which wants to encroach on your turf. There's just no way. So keeping equal distance and providing value to both of the big players was something which those big guys will engage in, and I've seen that being done between Google and Apple for the benefit of much smaller, less resourceful player in the market. So I want that protection from the big guys by the big guys. Again, martial arts, right? If somebody else can fight my war, I would love them to fight that war rather than engaging myself and limited resources. That's part of the answer. And the other part about theoretical versus or mathematical proof versus experimental. Well, we wanted rather than heuristics. If you go to the standard quantum computing startup and doing chemistry, they will say something and we'll use VQE. Come on. I do believe that VQE will not work for hard cases. And the easy cases are solved with the classical means. So where's the benefit, right?
Let me interrupt you for a second. Why you don't believe that?
Because it's heuristics. It's not proven to work for any instance. And the nature is kind of malicious in a sense that whatever is simple, you can solve easily. You can solve hydrogen atom, exactly, right? Add any complexity to that, and you'll have issues because you are using approximate methods, and you are assuming that you can separate the Hamiltonian into the non-interacting parts, making the whole problem much smaller. any exponentially scaling problem, if you can halve this and solve halves independently, you make for a much more efficient solution. And this is not a feature of nature, it is the feature of the hydrogen Hamiltonian, separating that into the spin, orbital momentum, and the Coulomb part, right? If you don't have that capacity, forget it. You will not get the simplification. So our path was the full formal inductive proof. Show that you can do this on the small scale. Best if you can do that experimentally. Best because we try to be hardware agnostic for the reasons I just mentioned. Show that on at least 2 different platforms. We had doubts going to ion trap machine. We had doubts because of the connectivity, and we thought that part of the benefits were that we were using the limited connectivity in a very clever way, which we did, right? But for the superconducting machine. But then we proved the same thing and showing that some of our techniques still work despite the full connectivity of the ion trap based machine. So we have established that you can do that part better than the classical, that any possible classical solution, because we use less queries and we still fit something, saving the factor of 10 in the number of gates you would need by the textbook methods, right? And then the mathematical part is the second step of an induction proof. We prove the scaling, saying that if you can do that at X, you can do that at whatever the number you want. And we have proven that formally. So this goes 2 ways, and in combination shows that our methods will scale with growing quantum computers, whatever the scale they might be at the moment where the commercial loads happen. So that was the idea, and it is a combination of the experimental proof for the small scale and formally proving the scaling that it will work whatever the scale you'll have.
Thanks. Yeah, thanks for sharing the details. I also see that André is very anxious to bring the conversation back to himself.
All right, André.
That's
Sure,
good. Beit.Tech, we're finishing with our quantum questionnaire, 6 rapid-fire questions that shall be answered with 6 rapid-fire answers. No Japanese martial arts, more Krav Maga. 1, 2 moves, okay? If you're ready, we'll get started. You can both answer or each, you decide. Who's your favorite scientist?
Feynman.
Who's your favorite entrepreneur?
Musk. Hey, you go. Yeah. It's fast. It's Krav Maga. I don't care, right? It's.
Paulina, you agree with Musk?
Yeah, of course.
Why is that? What is the quality that you desire most in an entrepreneur?
The quality of you desire most?
Bold decisions which look completely odd, but are coming from the deep thought behind. Japanese again, sorry.
What is the quality you desire most in a scientist?
Same thing.
Yeah, and brain.
Oh, you need brain for
to be the scientist. Yeah.
What is it that you appreciate most about working in quantum technologies?
Uncertainty and the potential of really making the changes.
What is your favorite, and it could be hypothetical, quantum application? And it doesn't have to be computing, it can be anything.
Okay, I would love to use quantum computing for the neurosciences and neurorehabilitation process.
Yay! Great answer.
And it wasn't just for you. She's studying psychology, so that's
neuro. So this is why I really loved your talk.
Oh, that's so great. We have to talk about that more. That's great.
What is your quantum dream, Beit.Tech?
Well, actually, I think that when it can make the difference. So the problems which are untractable for the classical simulation, classical computing, and can make the difference for this planet and humanity. Sorry for sounding like grand, but that's really what I think, right? Something which you cannot compute: protein folding, nitrogen fixation, stuff which matters for the planet and cannot be effectively modeled with the current means.
What is your quantum nightmare?
Okay, that there will be no quantum computers able to run hard stuff.
Imagine we have one tomorrow, it magically appears, fault-tolerant universal quantum computer. Who would you give it to? We only have one in the world. You decide.
Who would we get it to?
Oh, people working on the nitrogen fixation, the catalysis for the fertilizers. It's life or death, right? We cannot spend that much energy as we do for making our food.
Good. Dziękuję. Thank you very much. It was a pleasure to have you both, Paulina and Beit.Tech. Obviously, we could have been talking much longer and about a lot of different topics, so we hope to get that opportunity in the future. For now, I'd like to thank you for joining us. Thank our sponsors, INQ and my friend Denise, and Tropica Labs, still moving into a new office and expanding, so we want to hear about that maybe in a future episode. Thank you, Tommaso. This concludes Weekly Quantum World Detangled, Season 3, Episode 3, and you are now detangled.
Thank you.
Thank you.